here's what happens when we go to the dentist, right? Nitrous oxide, laughing gas, yeah, comes together with the oxygen we breathe to form nitrogen dioxide. Very, very good. First of all, are we balanced here in our equation? We always start the same way. Let's see. 1N, 1N. Oxygen, 3, 2. That's not good. Let's go ahead. What if we take this up to 2? But now we got 2 nitrogens, so let's go ahead and put 2 nitrogens over here. 2 times 2 is 4, and that looks okay. I think I'm balanced. So the mole-to-mole ratios are 2 to 1, gives us 2. Very good. You always got to do that first, yeah? That's the recipe. Now, this one is a little tricky. Now, if you don't understand this problem, don't worry about it a whole bunch. This is a real extension of what we're doing. Everything I've told you so far is easy because we are assuming that only one thing is limiting, and I told you what that reactant is. In this problem, I'm not telling you which one is the reactant that is limited. Who determines how much product we get? Well, let's take a look. I have 240 grams of nitrous oxide, 64 grams of oxygen gas. Okay, so first of all, I need to determine, right, who is the limiting guy. Let's take a look here. Well, the first thing I could tell you is the molar mass of nitrous oxide. You should be able to figure that out. Very simple, right? 14 plus 16 is 30. So, if we have 240 grams and the molar mass of it is 30 grams per mole, that means that I should have 8 moles of nitrous oxide gas. How about the oxygen? We're saying that we have 64 grams of it, and the molar mass of oxygen is O2, is 32 grams per mole. Very good. 64 divided by 32 is 2. You can see I did numbers to make things a lot easier, right? Okay, so basically what you've got here is 8 moles of nitrous oxide, and you've got 2 moles of oxygen. Now, if you just look at this ratio, even though it's 2 to 1, 8 to 2 is not 2 to 1. 8 to 2 is 4 to 1. So that tells me that I've got a lot more nitrous oxide than I need, and oxygen is the one who's limited. Okay, oxygen is limiting, so I don't care about this. So the amount of product will be determined by the amount of oxygen that I have. Let's go ahead and do it now. So that means I have 2 moles of oxygen, and we multiply it by the ratio. What's the ratio? You get 2NO. Oops, that's not 2NO. You get 2NO for every 1 mole, right? For every 1 mole of oxygen. So let's write that in there. 2 to 1. Okay, there we go. Let's do the math. 2 moles times the ratio 2 over 1 gives us 4 moles then of product, which is NO. And if I wanted to, I could take that even one more step here, right? By, oh, I'm sorry, it's not NO, it's NO2, right? Sorry about that. Let's put that in there, NO2, excuse me. If I want to, I could take it one more step by using the molar mass to convert that into grams. Now don't worry, that's a real tricky problem. I wouldn't hold you to something like that on a test, but if you understand it, you're really way ahead. Okay, so that's Stoichiometry Part 1. Next time, we'll put an additional step in there, and we'll talk about how to solve this using dimensional analysis.